Here's a little more info on the Deacy amp replica that I made. Question was asked, do the transistors get hot? They don't seem to get hot. Currently everything's off and they're sitting at 18 degrees, 19 degrees, or 66 if you're using Fahrenheit. So I'll turn them on, I'll turn it on. I've got it hooked up to my amp meter here as well, so you can see how many amps or microamps it's pulling. The tuning pot here is how you adjust your current draw. If you turn it one way, it'll increase your milliamps, which will increase the current, which is probably making transistors get hot. So we'll flick it on. I'm using a bench top power supply, so it's a little bit noisy, but it's set to 7.5 volts. 7.5 volts there. And we're currently pulling 13.4 milliamps. It's not plugged into anything, so it's just hanging there loosely. If I plug it in to the treble booster, it drops a bit. If I turn the treble booster on, yep, it drops it a little bit more. The guitar volume is turned down. So just make a little bit of noise. Just turn it up. You can see the amps changing there. It's back to 14 milliamps to draw, and the transistors have not changed temperature at all, really. I'll shoot them inside the cans if I can with the laser. 19.3. So no, it doesn't get hot. A couple of interesting things about the Deacy transformer. Obviously, there's very little information about the transformers. We know from the diagram that the audio driver transformer, which is this one, is 200 ohms on the primary and 100 ohms with a center tap on the secondary, so it's actually a reducer. And then the audio output transformer has 7 legs on it. So you've got your primary coil. There's always been debate about whether or not it's an auto transformer. I made an auto transformer initially, and that seems to work equally as well as this one. I guess but it's not DC isolated. And then I made a couple of these as well. The only variation being the number of turns on the feedback coil, which is these 2 pins here. So you can hear, well, I can hear my power supply, but if you can hear the slight hiss in the background, I'll just turn the volume up. If I put a dead short across these 2 pins here, it gets a lot louder. And interestingly, the milliamps drop just a smidge. So next experiment might be to put a short across there and see if the output volume increases. I would imagine it would. So this is the Deacy with the feedback coil basically shorted out. I've just got 2 alligator clips there clipped onto the top of the 2 center pins. Treble booster's on. It's got a really loud hiss. And if I turn my guitar, it's turned off at the minute. If I turn it up to full, it goes straight into feedback mode. So it's awfully loud. with that feedback loop shorted. And this is the volume without the feedback loop shorted. So guitar is turned down to minimum. I turn it up to maximum. Still feedback, but not as bad. The speakers I've just got off eBay, so they're 16 ohm speakers, both of them. Unfortunately, I had to cross the capacitor over there because your negative and your positive, you have to connect your positives together and your negatives together, and they're not in the same position on these speakers. So, but the speakers work pretty good. The heatsink is just made out of aluminium. I made that. I made a jig to bend the aluminium around, so it's nice and tidy. The first few I tried to manually bend, and they just looked horrendous. So that looks much better. The sliding pot there is basically Nigel's design. I saw that and that looks pretty easy to make, so I made one of those to fit in there, and I used the pins, these little gold pins here, for the legs. So I just soldered them inside the board, so they work quite well. The only really difficult part to find is your germanium transistors, but luckily that little record player that I found had most of them in it, and the readings were quite acceptable, so that's what I put in here. The box of parts that are left over. So I made a few coils. This one here is almost the same as what's in the Deacy at the minute. It's just got a few more turns on the feedback loop, so that one works quite well. It's just not quite as loud as what I've settled on. This one here was one of my first attempts at making the driver transformer. Again, it works, but the legs are in the wrong position. I hadn't thought that far ahead at the time. I just thought the legs were both on, the primary would be on one side and the secondary on the other. But no, not the case with this little transformer. These ones here I got out of an old 1966 or 67 little Philips record player. They also gave me the transistors that I'm using, or some of them. The record player itself was absolutely broken. The arm for the record player was broken, and the battery box was just full of corrosion. So it was a parts only, but the parts that came out of it were very handy for myself. This is the driver transformer out of the record player. You can see I've got solar on it. So this one here is actually meets the exact specifications that's in the Deacy. It is a perfect match. It's 200 ohms, 100 ohms on the secondary with a center tap. So that's across. This is the secondary winding, and that's the primary winding there, which is why I made my first lot of transformers with the legs all on the same side, because I built it over a few months and I'd forgot about the positioning of the legs, and I just wound it not thinking. But anyway, so I actually use this transformer to test out my audio output transformer, because I knew this one worked before I knew that my own coil there would work. So that one came in handy, but it's too small in comparison to fitting in the Deacy. So I continued to make my own. So there's the size difference. Like most things with technology, as time passes, everything gets condensed. So my transformers are made out of small electrical transformers that converted, I think, 240 volts down to 12 volts, I believe. I just bought them from China and pulled them apart. So I've used the core of that, and then designed some bobbins to print on. These are all resin printed. And then these are some ones that I tested. I think these are the first two that actually worked for me, that I pulled apart because I had the legs in the wrong position. So I had to pull them apart, and then I thought I'll just make some more. It's not that difficult. This is my winder from a CNC machine that I 3D printed. So the coils fit in there. You can see a slot, so as the wire doesn't get caught when I'm travelling back and forth doing the winding. So yeah, coils were an interesting thing to make, and now able to make coils. So this is the donor speaker, well, the other one that I used for my Deacy. A guy was selling these online for $30, so I just thought, yeah, I'll grab them. They look like they're decent old speakers. Hopefully they'll have some 16 ohm speakers in there, but they didn't, unfortunately. They had these Goodman loudspeakers made in England. They're both 8 ohm speakers, so I wanted to keep the Deacy speaky wiring, so it's two 16 ohm speakers in parallel with the capacitor between them. But I guess I could always wind a transformer capable of handling that. Yeah, so this was the donor. It's 90mm thick, so I milled it down to a thickness. Used the outer skin for the outer skin of my Deacy, obviously, and the timber, and then I just got some new front and back timber for the front and back. I reused the stuffing inside there, so I've got original 1970s stuffing in my Deacy, which is quite age appropriate, I guess. But we'll put my little speaker back together again, and I'll let you hear the noise that it makes. So just putting the wadding back in. And I noticed I've got this. So this is just cable I had around the house. I think it's from an old Dyson vacuum cleaner, I believe. So that's what I've used there. The other part that I wanted to get made that I didn't know about, as I hadn't seen, was the back piece here. So your PowerPoints. So thanks to Mark Reynolds for helping me out. He showed me a picture of his, so that's what's on the back. Originally, the backing that I had, it was brown, it's probably Bakelite, and it was rounded on the edges here, so I pulled the centre bits out and milled up some perspex to put it in there. And then I realised when I was soldering these things on that I didn't want to get the perspex too hot. So I was pretty quick solder that one, but that's the back bit there. So we'll put that other bit of wadding in, and we'll turn it on. There's your power supply. I'll just leave the multimeter there showing milliamps. The Deacy, obviously. Treble booster I'm using is one that I put together. It's got a BC 149 chip in it. So that's there, and the guitar is my homemade Red Special with my homemade pickups in it as well. So anyway, I'll set the camera down. Now I'll demonstrate the Deacy. Bear in mind I am still just learning to play the guitar, so I apologise if I hurt your ears in advance. Okay. So the transformer is on. The power supply is on. We're sitting at 7.5 volts. You can see the multimeter there showing 14 milliamps of power. Everything is switched on at the minute. My guitar is turned down. I'm just going to start with the bridge and middle pickup and just make noise, I guess. So I don't know if you can hear that at the minute. That's the power supply on. But as soon as I turn on the Deacy, you'll hear an immediate hiss. So that's the hiss. So that hiss was, and the milliamps went up. That hiss decreases with the more winds on the feedback coil that you put on it. Anyway, I'll just chuck my strap over my shoulder. And we'll turn the volume up. We'll go straight to full volume. And if you want to just hear sort of a sustain, whoa, single notes. Okay, and we're back. My phone went dead and I was talking to no one. That's always the case. Alright. We'll go back up to full volume again. I'll try something else. So it's got plenty of feedback, lots of noise. I'm sitting here and I think I need earplugs in. There it is.